Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good evening all. Okay, this week number 4, indeterminate structure. So we are going to discuss indeterminate trust using flexibility method. Basically, the procedure are all same. So we will apply as usual the principle of superposition to determine the redundant in the trust system. Okay, so of course, the first step to do is to calculate DOI. So we calculate degree of indeterminacy. For trust, we will use M plus R minus 2J. Okay, and also from that, we will identify whether the trust is internally, externally indeterminacy or internally indeterminacy. Because if the trust is externally indeterminacy, the redundant is come from reaction. If the trust is internally, previously is externally indeterminacy, redundant is come from reaction at the support. Internally indeterminacy, the redundant come from member force. Member force means we have to remove member from the system. Okay, and after that, as usual, we apply the principle of superposition. By applying the principle of superposition, we focus on displacement occur for each system. We will have primary trust and redundant trust, and from that we will determine reaction as well as internal forces. Internal forces in trust means member force, axial force in the member. So after that, we will substitute the member forces into the displacement formula. So displacement formula, so is different compared to the previous beam and frame, because internal forces now is N. And after that, we will determine the displacement, and after that, we will substitute displacement into the compatibility equation. And by solving compatibility equation, we will get the redundant, and after that, we will solve remaining reaction. Plus, we will also determine member forces in actual trust. Okay, member forces in actual trust. Reaction plus member forces. Forces in actual trust. Okay, using superposition method. So this trust, for trust analysis, even though we can calculate reaction using equilibrium equation, we actually can also use principle of superposition. And for member forces N in actual system, we better use the principle of superposition. It is easier than we repeat the method of joint to determine the member forces in actual trust. Okay, so this is the formula. I believe everyone have learned this previous semester, where degree of indeterminacy for trust M plus R minus 2J, M plus R minus 2J, M for member, R for reaction, and J for joint. Okay, if this DOI is equal to 0, means the trust is stable, the trust is determinate. When DOI is equivalent to 1 or 2, means this trust is indeterminate trust. And then we have to look at the support, the reaction at the support in the trust, because we have to understand that for determinate trust, for determinate and stable, minimum reaction must be 3 minimum. The minimum reaction which is come from support is 3, cannot be less than that. So in some cases where the redundant is come from member force, the reaction is 3 already. So we cannot remove 1 from reaction, because two reaction at the support, the system is unstable. So we must make sure that in the trust system is stable and determinate, minimum reaction we must remain at least 3 unknown reaction from support. Okay, so this is the first one that we need to check degree of indeterminacy using M plus R minus 2J. And then we have to check another one, N. N means that this is for the reaction. Reaction, we check the reaction in the trust. Okay, we minus by 3 equilibrium equation. Okay, and if this value This value is equivalent to 1 means redundant is come from support reaction. If DOI, if N, we call this as N, if N is equal to 0 means we cannot remove redundant reaction as the redundant, we have to remove member. Okay, it is like this, yeah? It is like this. So this trust, okay, this trust, when we check for member, it is 1, 2, 3, and 4. So this trust has 4 members. 4 members. So it is 4. The reaction, we have 2 pin here. So this trust has 2 pin support. It is 4. 4 plus 4 is 8. And join A, B, C, D, 4. So total is 0. Total is 0. Means that this one, DOI, is 0. So the trust is stable. The trust is determinate. Even though dekat sini, the trust has 2 pin support, but when we check for DOI, when it is equal to 0, the trust is determinate and stable. Minimum must be 3. We can also have trust like this when it has 2 pin support, but it is still stable and it is determinate, just like this. Okay, so move to another one. So this one, if we check for DOI using the first formula, M plus R minus 2J. Okay, now for members, we have 1, 2, 3, 4, 5, 6, 7, 8. So M is 8 plus R. R here is come from 1 pin, 1 roller. 1 pin, 1 roller. So this is 3. 8 plus 3. Join. There are 5. 1, 2, 3, 4, 5. Minus 2 times 5. So this is equivalent to 1. This is equivalent to 1. So DOI, okay, using the first formula, M plus R minus 2J, we get 1. Okay, then we have to check the support reaction. The support reaction. So in this trust, even though it is indeterminate trust, the value is 1. DOI is equivalent to 1. We cannot simply remove reaction as the redundant, because in actual condition, there is already 3 unknown reaction. Means that minimum must be 3. So we cannot simply remove 1 from the support. We cannot remove roller. We cannot just simply remove the roller support, because 1 pin in the truss system is unstable structure. We cannot also remove 1 from pin. So pin become roller after we remove 1. If the truss has 2 roller support, also the truss is unstable. Means that this is already 3 unknown reaction. It is minimum numbers for the truss to be stable and also determinate. So in this case, we cannot choose reaction as the redundant, because if we check for the reaction, so there are 3 reaction, we minus by 3, this is equal to 0. So this case, if this is occur, means that we have to choose member as the redundant. Member as the redundant. So so R, for this case, we should remove member. So normally for trust like this, we will remove either AD or BE yang ada intersection ni. Whether this, we remove this, or we can also remove this. Okay, and force in member BE like this. Force in member BE is the redundant. Okay, this is the case where redundant is come from member force. So this is internally indeterminate trust. Internally indeterminate trust. Previously, we call it as externally indeterminate. Okay, not previously. The previous one is DOI. Okay, when DOI is come from reaction, redundant come from reaction, it is called as externally indeterminate. When the redundant is come from member force, it is called as internally indeterminate. Okay, internally indeterminate. And in other cases, we can also have combination. For example, if we analyze trust, two redundant forces. So we can have one redundant come from reaction and another one come from member force. Combination of reaction and member force as redundant for 2 DOI. Okay. So let's look at another one. So this truss has one, two. Okay, this truss has okay, tak lekat. Okay, doesn't matter, just look at the truss. Just look at the truss. This truss has cuba bilang 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 eh. This has 10. This has 10 members. 10 members. Reaction is 4. It is 14. Join is 1, 2, 3, 4, 5, 6. So it is 14 minus 12. It is 14 minus 12. So the redundant is 2. Redundant is 2. And we check for the unknown reaction. There are 4 unknown reaction. 4 minus 3, 1. So means that one redundant is come from reaction and another one redundant is come from member force yang bersilang tu, either AE or BF can be the redundant. This is actually indeterminate thrust, combination of externally and internally. So label ni salah, betul kan? Okay, internally and externally indeterminate thrust because it has combination of redundant which come from support reaction and member force. Okay. So this one is 14 minus 12. 14 minus 12, so it is 2. So these 2, when we check for 4 minus 3, this is n, it is equivalent to 1. So redundant number 1, redundant number 2, we have 2 redundant. Redundant number 1, we can remove we can remove 1 from either D or B. So after removing 1, it become roller. We can remove BX, we can remove DX as redundant, and another one will be the member force. So yang ni kita boleh choose, for example, DX as redundant, and another one we can choose member force F AE. So dia combination macam ni, combination of reaction and member force for two redundant system. Okay, next. Okay, before we move further, I want to introduce you about effect of temperature changes and fabrication error in analysis of truss. Okay, analysis of truss. So this temperature changes and fabrication error actually affect displacement because when you first learn about displacement using unit load method, so please recall back. So displacement or deflection in truss system can occur not due to external loading only, but effect from temperature and also fabrication error, if occur, also contribute to the displacement. So using unit load method, masa kita belajar first unit load method last semester kan, so actually displacement ni under formula asal dia, formula unit load method, bila kita first learn about this method for determinate structure, so we learn about this formula and N kecil, N besar, one for real, one for virtual, over AE. So this is actually due to external loading. This is due to external loading. Okay, and if in the question has the effect of temperature, so actually it has another formula considering temperature that contribute to the displacement as well. Then the formula is N times alpha times delta T times L. N alpha delta TL. So the second one ni, this formula is whenever the thrust has temperature changes. Okay, and another one if the thrust is fabricated, has fabrication error. Fabrication error means for example AB ni, AB, this is the span lah, the steel span for one member. So let's say this span, the length is 6 meter, but during construction, the length of this member fabricated 6.01 or 5.99 for example. Okay, so dia tak dapat ngam-ngam 6 meter. So yang ni shorter than or longer than. So yang ni longer than lah. Yang atas ni longer than its original length. Yang bawah ni shorter than its original length. So longer berapa? 0.01. Shorter 0.01. So if the member is fabricated shorter than or longer than its original length, so yang ni masuk kategori fabrication error. So fabrication error also will contribute to the deflection in thrust, and the formula to consider this is N kecil ya. Semua ni ada N kecil. Kalau you perasan sini ada N kecil, sini ada N kecil, sini pun ada N kecil juga Okay, N delta L. So actually this is formula that you have learned under unit load method. Okay, means that deflection in structure, in thrust structure is actually come from number one, yang ni adalah external loading. This is external loading. Kat mana kita nak tahu dia external loading? External loading tu N capital ni. This is external loading. Okay, number two, the formula number two, alpha delta TL. N times alpha delta T L. So delta T tu is changes in temperature. Delta T ni is changes in temperature, and unit is per degree Celsius. Changes in temperature, sometimes cooler than, hotter than, or temperature increase, temperature decrease. Temperature increase, temperature decrease means changes in temperature will also contribute displacement in thrust. Okay, nanti mungkin sesi ni tak sempat nak tadi sesi yang pagi tadi 2 jam, saya sempat tunjuklah end of the class tu, masuk dekat ChatGPT and tanya chatting about this effect lah, how it affect the structure. You boleh tengok video tu lah, tapi nanti untuk you all punya kelas, nanti saya akan tunjuk dalam kelas 2 jam. Okay, so delta T ni is changes in temperature. Unit dia is degree Celsius, and please remember yang kita sedang buat ni adalah displacement. Displacement mesti dalam unit meter. Bila displacement mesti kita produce in unit meter, jadi delta C tu kita kena cancel. So untuk cancel delta C tu degree Celsius tu bukan delta C, delta T. Degree Celsius tu kita nak cancel, kita kena kalikan dengan alpha. Yang ni alpha. Ini alpha alpha. Alpha means coefficient of thermal expansion. Coefficient of thermal expansion. Ni alpha ni ataupun tadi dalam bahasa ChatGPT dia buat singkatan STE. Coefficient of thermal expansion. CTE ya, coefficient of thermal expansion, yang mana unit dia adalah per degree Celsius. Unit ni adalah per degree Celsius. So kalau unit dia per degree Celsius dengan degree Celsius, so dia akan cancelkan this degree Celsius unit. So dapatlah unit daripada length which is meter lah, meter. Okay, N kecil tu, N kecil tak ada unit. N kecil is member force in virtual system. Virtual system tak ada unit. Okay, virtual system tak ada unit, sama macam redundant system also tak ada unit. Okay, primary structure ada unit, redundant structure tak ada unit. Okay, so satu lagi yang tadi saya sebut longer than, shorter than, it is fabrication error. So if member BC is fabricated 10 mm shorter than its original length, or 5 mm longer than its original length, so normally occur during construction. Okay, so yang tu how to include into the displacement calculation, it is just as simple as this. Okay, it is delta L sebab dia total lah. Sometimes maybe the trust kan dia ada banyak members, so in reality maybe ada more than one member yang get affected. Tapi untuk analysis calculation ni mungkin kita akan just consider one member or maximum pun 2 member sahaja. Tapi in reality mungkin akan ada banyak member yang get affected. So that's why dia ada summation tu, summation. Okay, so means that kita do one by one member. Ada member yang okay, 0 lah. Ada member yang ada dead elongation. Okay, ataupun dia kurang contraction or elongation. Okay, so dia akan ada value lah for delta L. Okay, so tiga-tiga ni persamaan dia, tiga-tiga ada N kecil ni. Tiga-tiga ada N kecil. Apa dia N kecil? N kecil ni apa? N kecil, yang ni sebab formula unit load method ya. So small n is member force. Member forces in virtual system. Virtual truss. So itu N kecil ya. So setiap satu ni ada, nampak ada N kecil. N kecil. N small n. Untuk tiga-tiga formula. N small n ni tak ada unit. Dia member force yang tak ada unit sebab virtual load, a unit value tu tak ada unit. A unit value tu tak ada unit. So this is virtual load yang kita apply into the system and a unit value tak ada unit. Okay, so bila kita introduce, kita apply lagi sekali, so all this dalam flexibility method, so semua N kecil dia akan jadi N redundant. N redundant. So N redundant N1 lah. N redundant adalah N1 because N naught is for the primary system. So N redundant N1, ada case yang N redundant N2. Depend. Okay, so means that nanti dalam formula for flexibility method, semua N kecil tu kita akan ganti dengan N1, N1, N1. Formula lain sama. N1, N1, N1. So ini dia formula asal tadi. Formula asal yang ada dalam buku teks Hibbeler. Please refer to chapter 9. Chapter 9, deflection unit load method. Okay. So now we move to examples. Sempatlah saya nak explain, tak sempat buat latihan. Tak apa, nanti untuk latihan, you boleh tengok saya ada buat, tadi sempat buat satu full, satu lagi half. Tapi half pun sampai habis, cuma tak isi, tak fit in the blank lah, tapi sampai habis. Okay, so one redundant truss, soalan macam biasa. Soalan dia adalah kita nak kira reaction and member forces. So ada tambahan ya, kalau for beam and frame, soalan dia kita just nak calculate reaction at the support. Tapi kalau dia truss analysis, dia not only reaction, tapi member forces. Reaction and member forces is the goal. So ini kita punya target lah. Ini kita punya goal. Okay, yang atas-atas tu semua dia punya step je lah. Okay, compatibility equation ni kita kena cari because dalam compatibility equation tu ada redundant. So we can get redundant by solving the compatibility equation. Okay, so this is just simple truss. This is actual truss. Actual truss. This truss has 2 pin support. Ada 2 pin kat sini. If we check for DOI, for it is M plus R. M ada 3, M plus R ada 4 kat sini. Okay, R ada 4 minus 2J. 2J. J is 3. J is 3, so we get 1 here. 1 here. So, and if we check for N, it is 4 minus 3. So, if this is equivalent to 1, means that reaction dia mesti salah satu daripada pin tu. Okay, mesti salah satu daripada pin. Dalam kes ni kita tak boleh buang member. Tak ada yang bersilang pun kan. So, tak boleh buang member, kita buang support reaction. Support reaction. So, this is the thrust, the thrust to the first degree of indeterminacy. This is externally indeterminate. Externally indeterminate. So, R kita boleh buang either AX ataupun kita nak buang CX. So, by removing either one, so kita akan dapat satu pin, satu roller. So, this is actual thrust. Okay, so kita akan, so from this, okay, let's say CX is the redundant, means that we will remove CX. So, we apply the principle of superposition. Sama je macam previous, bila kita dah decide redundant, kita dah patut boleh terus tulis the equation. The general equation, actual thrust equal to primary thrust plus redundant thrust. And in this case, CX is CX that is applied into the system. So we use CX applied for the redundant thrust. So it is actual thrust equal to primary thrust plus redundant CX applied. Okay, so in primary thrust, in redundant thrust, there will be displacement delta 1 node and F11 sama je macam previous beam and frame. Delta 1 node and F11. Delta 1 node and F11. Dia R kan? R ni CX. Okay, so kita tak nak pakai C, kita pakai 1. Okay, kita boleh pakai simbol 1. Okay, so kita tukar semua simbol 1. So, delta 1 node and F11 kali dengan redundant CX is equal to 0. This is the compatibility equation. Dalam this compatibility equation, dia ada 2 displacement, delta 1 node and F11. Delta 1 node is displacement in primary thrust, and F11 is displacement in redundant thrust. Formula dia sama je macam unit load method. Unit load method formula dia N kecil, N besar, L over AE. Okay, N kecil apa? Virtual system. N besar real system. Karakteristik dia, yang virtual system tu adalah redundant system. Same karakteristik. Okay, redundant system, and N capital kat sini is real system. Karakteristik dia sama dengan primary system. Primary system. So, jadilah dia N1 and not L. N1 and not L ikut label dekat sini. And then we have F11 N1 square L over EA. So, this is the 2 displacement formula. So, inilah dia yang saya selalu cakap, sebenarnya compatibility equation bila kita faham, kita akan tahu apa kita nak buat. Next step tu ada pada compatibility equation. So apa yang kita buat is actually to fulfill compatibility equation. Sebab pada compatibility equation ada displacement as unknown. Ada redundant as unknown and ada displacement yang kita boleh calculate the value. Okay, so there are 2 displacement. Theta 1 node and F11, and dalam this formula dia ada N node and M1. Sama macam beam dengan frame. Beam dengan frame, internal forces tu reflection kepada moment equation M node and M1. But for thrust system, N, we use N for internal forces. Member forces is internal forces, so we use N. N not N1. So macam sebelum ni juga, N not is for the primary thrust and N1 is for redundant thrust. N1 for redundant thrust. So apa yang kita kena buat dekat sini? Kita kena analyze primary thrust untuk dapatkan N not. Kita kena analyze primary thrust untuk dapatkan N not. Jadi N not tu is a must. Sebab and not tu yang kita nak masukkan dalam formula. Jadi, in order to calculate and not, which is member forces in primary thrust, kita kena calculate dulu reaction. So, reaction ni kita kena calculate reaction. So, kena apply equilibrium equation. Calculate lah macam biasa, reaction at the support. So, dekat sini pin lah, dekat sini pin. Tapi, because tak ada pun horizontal reaction dalam this system, so still nilai CX tak, nilai CX pula kat sini yang pin silap. Sini dari roller kan. Okay, sini pin ya. Okay, sebab there is no horizontal force applied into this system. Just ada 200 kilonewton vertical load, no horizontal load. Jadi AX tak ada value lah, even though it is spin, value is 0. So yang ada dalam ni is only vertical reaction. Vertical reaction. And since this triangular, this symmetry, belah sini 3 meter, belah sini pun 3 meter, look symmetry kan, that 200 tu dekat tengah-tengah. So bila kita calculate reaction, kita akan dapat samalah 100 and 100. And actually, bila kita analyse thrust, dia senang je. Kita kena check dua benda, externally and internally. External equilibrium, internal equilibrium. External equilibrium means 200 ni mana dia punya balancing. 200 tu mana dia punya balancing dekat support. Dekat support. So dua-dua ni mesti dapat balik 200. So the system, the thrust is externally in equilibrium. Okay, so beside external equilibrium, which we check for the whole thrust, we also need to check for internal equilibrium. Internally, we have to check internal equilibrium. So macam mana nak check internal equilibrium tu, itu member force. Internal equilibrium means method of joint. Internal equilibrium means kita kena check dekat setiap joint mesti fulfill juga total Fx 0 and total Fy 0. Mesti kena check. Kena check internal tadi tu. Joint by joint kena check. Okay, so yang ni mungkin tak sempat nak tunjuk sekarang ni. Okay, tapi the idea is kita kena check kat sini. Kena check dekat sini and kena check dekat B ni. Kena check. So, dia mesti fulfill total Fx 0, total Fy 0. Total Fx 0, total Fy 0. Okay, saya tunjuk kat sini sikit. So, ini simple lah, straightforward. Sebab just a simple thrust, this is 200. Okay, so sini ada tadi pin dengan roller. So pin dengan roller ni kita check for, sebab dia 3 meter ni, 3 ni. Memang dah tahu dah yang ni is 100, yang ni is 100. Sebab dia simetri kan. So AX tak ada value lah. AX tak ada value sebab tak ada apa nak balancekan dia. So dia memang 0. Silap. Okay, so externally dah stable. Externally in equilibrium. Now kita kena buat for members pula. For joint tu kita dapat member force. Okay, so in this case kita kena check setiap joint. Sini A kan, sini A, sini B, sini C. Kita kena check dekat A macam mana dia balance kan. Okay, for example dekat A, kalau ada 100 macam ni, so mesti ada 100, yang ni 100 going up, right? 100 going up, mesti ada 100 going down. Dia mesti ada positif, mesti ada negatif. So that kita dapat 0, total Fy 0. So dalam case ni, kalau kita belajar dulu method of joint kan, So ini joint A kan, kita akan buat, okay, sini ada satu, ini FAC. Sini ada incline, sini FAB. Ni yang kita buat masa method of joint. Lepas tu FAB ni sebab dia incline, kita resolve in X, resolve in Y kan. Lepas tu yang ni 100. So kita pun apply lah total FX, kira total FY, kira kan. Total FY, kita kira kan. Okay, so this is the idea. Ni idea dia yang ni. Maksudnya yang kita buat sekarang ni adalah method of join juga, tapi kita tak tulis semua ni dah. Okay, sama macam sebelum ni saya cakap, moment equation relation tak payah tulis kan, tak payah tunjuk kan. Sama juga, yang ni pun tak payah tunjuk ni, yang this side ni tak payah tunjuk. Okay, this is knowledge yang kita kena tahu. Okay, kita kena tahu yang kita apply, dan kita apply dalam flexibility method. So tujuan dia kita nak buat balancing. Okay, nak buat balancing. Balancing tu kalau kita dah biasa buat, dah faham, it is quite simple and straightforward. Okay, dia konsep dia total fx0, total fy0. Ada yang kita check dengan, kita buat y dulu, ada yang kita buat x dulu. Macam case ni, macam case yang ni kan, yang case ni sekarang ni, yang FA, yang ni lah, yang, sekejap, tunjuk, ni sini, ada sini. Maksud yang ni, kita nampak kat sini, kalau x, ada dua unknown, ini x, ini pun x, ada dua unknown in x. Tapi y ada satu je unknown. Jadi y yang kita buat dulu. Y kita buat dulu sebab y ada satu unknown. Tapi x ada dua unknown. That's why y ni kita terus dapat 100 negatif. 100 negatif kita letak dekat mana? Letak dekat incline member. Letak dekat incline member. So incline member bila kita dah buat y, kita kena buat x. Bila kita buat dah dapat x, kita kena buat y. So automatically sebelah ni kena buat dulu. So dua-dua tu kena completekan dulu. Vector using vector, so kita kena completekan dulu. So 100 kita kena use trigonometry and interpolation untuk dapatkan nilai x tu. Nilai x. So kat sini 3 sini 4. 3, 4. Yang ni trigonometry lah. Trigonometry. 3, 4, 5. Jadi 100 tu 100 for y. So berapa nilai x? Kalau 100 for y berapa nilai x? Based on trigonometry 3, 4, 5 ni. So itu kita kena buat. So all this kita sebut sebagai easy method. Easy method sebenarnya adalah method of join which we do it virtually. So kita tak buat lah. Yang ni kita tak buat. Kita tak buat satu demi satu. Sebab kalau buat yang ni memang lambat lah. Memang lambat. So kita akan buat dengan cara yang lebih pantas. Okay, kita akan guna easy method. Kita just buat balancing. Okay, so number 1 kita akan letak negative 100 tu sebab dia akan balancekan reaction 100 dekat support A, dekat pin A, and then dah dapat negative 100. It is for incline member. So once we get y, we should get x. Okay, we use trigonometry. Trigonometry kita tengok dia punya ni lah. Boleh pakai sudut tapi saya lagi suka pakai trigonometry. So guna trigonometry 3, 4, 5. So if 4 is equivalent to 100, 3 is equivalent to what? So yang ni kita pakai interpolation. Okay, berapa nilai x tu? It is 75. Okay, dia macam ratio je kan. Kalau 4 jadi 100, kalau 3 jadi berapa? Dia macam ratio. That is interpolation. Interpolation. So kita dah dapat 175. Yang ni vector kan? Vector. So vector dia ada resultant force. Resultant force. Okay, yang ni resultant force. Yang H ni lah. H ni kan? H5 ni maknanya kalau 4 is equivalent to 100. 3 is 75. 5 berapa? 5 is 1 to 5. 5 is 1 to 5. So this is how we actually analyze trust. Analyze member forces in trust using easy method. Okay, so dekat A tu for y dah settle. For y dah settle because 100 dah balance dengan 100 kat bawah tu. Dah ada 100 negatif, dah ada 100 positif. So dah total 0 lah. So now dekat A tu dia ada 75. Dia ada 75 ni yang belum balance. Belum kita buat balancing. So bila ada 75 ke kiri, mesti ada 75 ke kanan. So 75 ke kanan letaknya di member AC. Member AC. Okay, member AC. So kita dapatlah nilai ni 75. 75. Okay, so dia sebenarnya sama dua belah. So dapat dekat C tu 75 negatif, dapat sini pula 75. Dapat sini pula 100. So 100 ni sama dengan 100 ni balancing. So dapat pula atas ni dengan kiri ni. So yang ni 100, sini 75. 75. So sebelah sini pun sama. Okay, this is 100, this is 75. So for join B total FY 200 yang ni. Mana dia punya highlighter ni? Okay, 200 ni, 200 negatif. 100 ni positif, 100 ni positif kan? So dia dah jadi kosong. Sama juga dengan total FX. Total FX kita ada positif 75 and negative 75. So dia dah dapat kosong. Okay, so setiap join tu kena check. Sama juga dekat A. Dekat A, 100 positif, 100 negatif dapat kosong. 75 negatif, 75 positif. Positif dah dapat kosong. Sama juga dekat C ya. Dekat C nak buka dapat orange. Okay, so dekat C pun sama. 100 ke bawah, 100 negatif, ada 100 positif. And 75 kanan, ada 75 kiri. Okay, so itulah dia internally in equilibrium. Internally in equilibrium macam tu. So externally tu kita check external loading dengan reaction. External loading and reaction, dia mesti dalam sistem tu dia ada balance. Dia balance. So kalau ada real ataupun external loading, so external loading mesti dibuat balancing dengan reaction. Tapi for join kita kena buat macam step tadilah. Okay, macam step tadi tu. So kita akan dapat member forces. So member forces ni 1 to 5 jugalah. 1 to 5 the hypotenuse. Okay, and arrow dia macam tu. Yang ni guna konsep vector. So in order to determine member forces in the primary thrust kita buat step ni. So banyak kat sini kita apply trigonometry, vector, apa lagi? Interpolation. Trigonometry, vector, interpolation. Kena apply bila kita nak buat, kita nak calculate moment, kita nak calculate member forces. Okay, we do it, it is method of join, but we do it virtually. We call this as easy method. So easy method ni bukan method yang ada dalam buku ya. Cuma kita sebut je easy method untuk panggil benda ni lah. So this is easy method. So for flexibility method, memang kita kena pakai easy method. Okay, kita tak boleh buat yang belah kanan ni. Belah kanan ni tak boleh. Sebab yang ni akan buatkan kita punya, akan take time lah. So bila nak siap kan. So actually benda dia macam ni je. Okay, so the same example saya dah discuss dalam video group A pagi tadi. So you boleh tengok yang tu jugalah. Okay, so nanti for another 2-hour session. Nanti saya akan inform you back sama ada Jumaat ni ada kelas. Kalau tak ada, kita gantikan dengan kelas fizikal minggu depan. Kita cari slot untuk buat kelas fizikal lah minggu depan. Okay, so kelas untuk group B CS 5 to 7 sampai sini. Okay, saya stop recording kejap.